Chapter 3 Thermodynamic Properties of Fluid. Now we come into the thermodynamic properties of fluid. Fluids consist of two groups, that is liquid and gases. Gases are very much compressible fluid, hence thermodynamic properties plays an important role in the case of gases. While liquids are almost incompressible, hence thermodynamics doesn't play an important role in the case of liquid. The relationship between absolute pressure, specific volume and temperature of a gas is defined by ideal gas law. Ideal gas law. Ideal gas law in the form of an equation states that PV is equal to RT, where P is the absolute pressure. Absolute pressure is measured by taking vacuum as the reference, that is, vacuum pressure is taken as 0 and all other pressures are measured by taking this vacuum as a base. V is the specific volume or volume of a unit mass of gas. In terms of density, it can be expressed as specific volume is equal to 1 by rho, that we have already discussed. R is the gas constant. Hence, the equation 1 becomes P by rho is equal to RT. If we consider the equation for m mass of gas, then the equation becomes PV is equal to mRT. Different types of processes. There are different types of processes in thermodynamics. Each process, any one of the variable will be kept as constant. Isothermal process. If the change in density occurs at constant temperature, then the process is called isothermal. Then the ideal gas law becomes PV is equal to a constant because T is no longer a variable, it's a constant. R is already a constant. Hence, PV is equal to a constant. Day-to-day life example is evaporation of water inside a pan is an isothermal process. This is because as the water starts evaporating, the temperature of the water remains at 100 degree till the entire water get evaporated. Hence, the entire process take place at constant temperature. So, it is said to be an isothermal process. In Carnot cycle, one of the stroke is said to be isothermal. The heating of air inside a cylinder take place at constant temperature, then the process is said to be isothermal. We can observe the process in the above figure. Here we plot the values of pressure and volume on xy axis. Then we get a curved nature as the result. This is because the product of pressure and volume is always a constant in isothermal process. If the product of two values is a constant and if we plot the two values on xy direction, xy axis, then the graph looks like this. The PV diagram in the case of isothermal process also looks similar to this because the product of pressure and volume is always a constant in isothermal process. Adiabatic process. If the change in density occurs with no heat exchange inside and outside a system, the process is said to be adiabatic. Adiabatic process is actually an isolated process. Thermal flask is an example of adiabatic system. In the case of a thermal flask, there is no exchange of heat with the surrounding, hence it is adiabatic. If the expansion of gas takes place inside an insulated system, then the process is adiabatic. Only exchange of work takes place, no heat exchange. Let us consider a case in which a piston is allowed to expand inside a thermal flask. Then the process can be said to be a perfectly adiabatic. However, in real life situation, in Carnot cycle, one of the stroke is said to be adiabatic expansion. In that case, the piston is not completely isolated. However, the process takes place so quickly that there is no actually time for heat exchange with the surrounding. Hence, that stroke is said to be an adiabatic expansion process. In adiabatic process, the relationship between pressure and density is given by an expression. The expression is P by rho raised to K is a constant, where K is the ratio of specific heat of gas at constant pressure and volume.